process of transcription for prokaryotes follows this general pathway, where a DNA template strand encodes for an RNA strand, which then encodes for functional proteins. This DNA template strand runs from the 3' to the 5' end, wherein the RNA strand then matches that, running from the 5' to the growing 3' end. While it grows, it makes what are called phosphodiester bonds, which are the backbones of both of the DNA and the RNA strand. The encoding nucleotides are a little bit different than eukaryotes, where we use ribonucleoside triphosphate, which encode for A pairing with U and C pairing with G. Consensus sequences are considered the most common order of nucleotides in a specific segment. The process of initiation requires the binding of the RNA polymerase, which will then encode for the nucleoside triphosphates on the RNA strand. This can be represented by an airplane. An airplane sitting on the pavement is of no use to us, because it requires wheels in order to allow it to lift off and continue moving in its desired destination. So this core RNA enzyme is then bound by a sigma factor, represented by the wheels on a plane, which allow it to be rooted down into the -35 and -10 consensus sequence regions. These regions allow for the RNA polymerase to move forward and begin encoding for nucleotides. Nucleotides begin encoding at +1 and then continue to the right, moving in the 3' direction of the RNA strand. Once it's gained enough momentum, which is about 9 to 12 nucleotides down the line, the step of elongation continues and the sigma factor, aka the wheels on the plane, go away. They're no longer necessary for the airplane to take flight. So this RNA polymerase continues down the line until it reaches its terminating factor. The step of termination can occur in two different fashions. Here, we're going to talk about row-independent termination. This can occur due to an inverted repeat in the DNA strand that encodes back on itself. Seeing that C binds with G, T also binds with A, and G binds with C, followed by a continuous sequence of A's, we can see this here on this strand, where G and C can now bind together, and T and A can bind together, and then C and G can bind together. This inverted repeat causes a hairpin loop, which, as the RNA polymerase travels across, causes the RNA polymerase to slow down, which then causes the RNA strand to release from the original DNA strand. This ends in what is called row-independent termination. If there happens to be a 5 base pair insertion between the -35 and the -10 box, we would see that the space between the -35 region and the -10 region would be much larger. The consequences to an organism, say E. coli bacteria, with this insertion at the promoter region would find themselves unable to root properly into the promoter, which would inhibit its ability to move forward in transcription, just as an airplane would find it hard to move forward into the air without its wheels. This would cause the E. coli bacteria to become inviable, as it cannot produce functioning proteins for itself.